Yeah. Okay, so this is basically what we have to integrate over this curve mod of z is equal to 1. So firstly, you could start by simplifying the denominator here, writing it in term of the points at which it's not analytic, and I took it as I. Okay, so you get z square common and z minus 2. So the points at which our function not analytic is z equal to 0 and z equal to 2. Nicer. Now if you draw a graph for that though, we know that mod of z is 1 now. So if you start from 0 and go till 1, we'll have 1 and minus 1. So our function can take values only in between 1 and minus 1, anything and everything in between. So if you look at 0, 0 is right here now. But if you look at 2, 2 should be somewhere around here. Since 2 is outside our region, we do not really need to consider it. So basically a function is only not analytic at 0 because we are only considering this region. We are not concerned with 2 at all. वैसे. So we could rewrite the function as phi of z upon z square dz, where phi of z is z plus 1 upon z minus 2. Now by Cauchy's integral theorem, we can see that the integration, इसका integration would be is equal to phi dash of z naught. Z naught in our case is 0 now. So phi dash of 0 into r2 pi I upon n minus 1 factorial. Here our n ka value is 2. Okay. So it will be 2 minus 1 factorial, which is 1 factorial. If you want, you can even have a look at the formula. This one over here. If you have a function like this anytime, f of z upon z minus z naught, over here I taken it as phi of z. Okay. So now over here z naught ka value is 0 basically. And power of n is 2. So the formula becomes 2 pi I times the derivative of the function upon n minus 1 factorial. Since n was 2, we get 2 minus 1. We get 2 minus 1 factorial, and over here we get the single differentiation. Basically, if this is 2, then we have to differentiate this once. If this is 3, we need to differentiate this twice, and then put value of the point at which is not analytic, z naught ka value, which is 0 in this case. Okay, since we don't have this, we could just calculate it from this now. Now differentiating this dude. Okay, so we'll get pi dash is equal to we use the u upon v rule. So differentiation of numerator into denominator minus differentiation of denominator, which is again 1, into numerator. If you see, this z and this z will get cancelled, and we'll get minus 3 in the numerator, and in the denominator we'll have z minus 2, basically the denominator ka whole square. So we get minus 3 upon z minus 2 ka whole square. This is phi dash of z. However, we are not concerned with phi dash of z. We want phi dash at 0. So we can just put the value 0 and see what we get. We get minus 3. If you put a 0 here, get minus 2 ka square, which is basically 4, positive 4. So we get our value as such. And if we write this as I, so we get I is equal to 2 pi I into this dude. This dude was here, dash. Minus 3 by 4, 2 ones are 2 twos are. So we get I is equal to minus 3 pi I by 2. Oh, sorry, I forgot to show the thing. Me